we don't have control over the TD. The manufacturer controls the TD on the casing.
Well, in the instance where we were setting a low pressure switch for temperature control, so did we kind of did have control over the TD in some level?
Well, not over TD you didn't. You're just controlling cut in and cut out is all you're controlling.
Right.
So you're not controlling TD. You're controlling, what temperature the box is cycling on at and what temperature the box is cycling off at.
Right.
Superheat that coil is running. So the TD is the TD on the coil. Whatever the coil manufacturer says the TD that I want on this coil, that's what it is. So over cut in and cut out, you don't have control over that TD. It's just cut in and cut out. So on your TP charts, if you look on that Sporlan TP chart that I made now, it's actually got cut in and cut out on the pressure control setting. On the bottom here, it's got some guidelines on that for your different boxes and your different temperatures and your different products inside your boxes of what your guidelines are for it. That'll get you close if you don't have anything, but you always dial it in to whatever the customer wants or what they think they want. Sometimes what they think they want and what you can actually do are two different things. Okay, so TD is very important in our field because you could be working on two identical cases that look identical to one another, and they could be running two different TD ranges because they have two different applications. So like a forest box, you're going to have more TD than you are on a soda box. The forest cases sometimes will throw you a fit when you're working on them because your evaporating temperature is up so high on them and you can't figure out why. It's because you're running more TD on the coil. Yes, sir.
Years ago, I've heard that chocolate cases, like fancy chocolates that you would see at like famous bar or wherever, those were supposed to be the most difficult to dial in. What would you do with something like that?
Well,
because you wanted very low humidity.
Yeah. Candy cases sometimes can be. Normally with candy cases you have AEVs on them, automatic expansion valves on candy cases. So you normally set those to whatever suction pressure you want, and that's going to give you your suction temperature. So they're not real good on high load applications. So normally they're normally fed off of another case. So candy cases can be difficult to work on because normally they don't have a thermostat in them by themselves. So sometimes they are a little bit more difficult to work on. All right, so condensate drain. So does anybody know when we have to trap a condensate drain? On an air conditioner, on a reach-in, or anything? When do we have to put a P-trap on a condensate drain?
If there's a difference between the air pressure.
We got a pull-through coil. So what do you mean by a pull-through coil? That's right. So anytime that we've got our evaporator coil on the negative side of the blower.
Right.
So if the evaporator coil is on the return side of the blower, you've always got to put a trap on. And I can't tell you how many cases I've worked on out in the field. How many cases I've worked on out in the field. The guys don't have traps on there, and the unit will work just fine, except for it rains water every time the unit shuts off. That's because the trap is either missing, because somebody don't put it on, or it's got a crack in it. And that's very common when you're coming out of winter and going into summer, going into spring. And that water sits in that P-trap, and when that water sits in that P-trap, it puts a crack in it. So what we're talking about a P-trap. The P-trap looks like this. You got a trap below the coil level here. And the top of the trap is not above the pan. Now, if your trap came over here like this, it came out there like that, that is not a P-trap. Water will seek its own level. Okay, so you always need to make sure when you're trapping a coil, you're coming out, oops, that ain't gonna drain quite right. You come out below the bottom of the pan, because water will seek its own level. So anytime that you have a P-trap on the negative side of the blower, now, if you're that one on the positive side of the blower, then I wouldn't watch my arrows.
You can make them curvy.
You can make them curvy? Yeah, you can make them curvy as long as this line here is not above the bottom of your pan. You can put another one in there if you want. What do you mean? As long as that's not above the bottom of your pan, it's going to work just fine. You just double trap it. Yeah, as long as you can, like this coil here, see here how our drain is on the negative side of the blower? It's not on the positive side of the blower. So anytime that your drain line is on the negative side of the blower, you always got to trap it. And that holds true in any situation, air conditioning or refrigeration. Typically in refrigeration, we don't run into this too much, but air conditioning, we run into it all the time. And what happens is, in the wintertime, when this unit sits idle, that water stays in that trap, and what happens here is that trap will break, just a little hairline crack in it. It'll break because the water filled up the trap, expanded and broke in the wintertime, we put a crack in it, and when it put a crack in it in the wintertime, then when it goes to start off in the summertime, the unit will go ahead and work, but it's sucking air into that trap, and it won't allow that trap to drain. So you've got to make sure that you check those on your preventive maintenance checks in the spring on your air conditioning checks. Check them traps. Now in the winter, we don't have to check the traps in the winter, but the summertime, when you go to put those, when you go to the air conditioning startups, you want to make sure you check the traps. Refrigeration, if you got one that's not draining, it's leaking water all over the place. If you got icicles hanging below the evaporator coil, check the traps if it's got one on it. Because it might be that the tape, the heat tape on your condensate trap might be bad and froze the drain up on it. So,
Can't you just put the drain on the positive side every time? You wouldn't have to do it then?
no, because a lot of times it's not on. You don't get to dictate where the drain goes. The manufacturer dictates where the drain goes. Anytime that you have an electric furnace, typically your drain's going to be on the negative side of the blower. Anytime on an electric furnace activated. On a downflow furnace, anytime you got a downflow, normally speaking, your drain's going to be on the negative side of the blower. On a rooftop unit, it's all going to dictate on where the manufacturer puts the drain pan. If they put the drain pan. Normally speaking, on a rooftop unit, they're on the negative side. Normally speaking. I've only seen a very few that are on the positive side. Normally they're on the negative side.
And they stopped supplying P-traps with almost every rooftop unit. So now you got to go buy one. Almost every. They used to be on the inside of the unit, you know, like taped to the side.
Everyone that I've ever reported, I've always had to buy them.
Seriously?
Yeah. Normally you make them up out of 90s, what you make them up out of.
Nah.
Make them up out of street 90s or regular 90s. Because they're normally all 3/4 or 1 inch is what they all are. One, anything up to about 20 tons, and then they get bigger from there. But typically up to about 20 tons or even 3/4 or 1 inch. So you always got 3/4 or 1 inch fittings on your truck for doing condensate line piping. So I just always made them up out of 90s. They do sell preformed P-traps. Like I use those. I never did get those. On condensate P-traps. Now, piping P-traps is completely different. We're talking about condensate P-traps. If you've got an evaporator coil, if you've got a box temperature that's operating below 32 degrees, so what temperature does water freeze at? 32. So if I've got an evaporator coil, or if I got a box, it's just sitting inside of a box, and my box temperature is at 0 degrees. I'm still draining water off my evaporator coil, because I've still got humidity in the air. So when I go into defrost, and we're going to talk about defrost, when I go into defrost, I got to keep my condensate warm, my trap warm, or my line warm with something. So normally we use heat tape is what we use to keep that condensate line warm. So if that heat tape fails, if it burns open or shorts, then what's going to happen is your condensate line is going to dry, it's going to freeze up and it's going to break your condensate line because you're below 32 degrees.
How far does that go?
It doesn't break it.
Is it
I've never seen it anyway.
So typically, on your air conditioning, you're going to be running about 25 degrees TD across the coil, and on your reach-ins, you're going to be typically running about 20 degrees TD across the coil. Right? On your walk-ins is where you're going to be running your 10 degrees TD across the coil. But I have seen reach-ins running 10, 15 degrees TD, and I've seen walk-ins running 15, 20 degrees TD. Okay, so you have to make sure that you check your TD. And how do we check TD?
With a thermometer.
What's our formula for checking TD?
Evaporating pressure and evaporating fan.
Return air temperature.
Return air temperature minus our evaporating temperature. That's our TD. So our return air coming across our evaporator coil minus our evaporating temperature is going to give us our TD. So if I got 40 degrees coming across my coil, and I got a 20 degree evaporating temperature, That gives me 20 degrees TD across that coil. That is not the same thing as delta T. What you guys were taught in third semester. Delta T is your RAT minus your SAT, gives you your delta T. Delta T is return air temperature minus your supply air temperature, gives you delta T. That's not what we're talking about here. We're talking about TD across the coil, temperature difference on the coil, not delta T. Okay? So on a walk-in, it's very typical to have multiple units on a walk-in. So when you have multiple units on a walk-in like this, right, you have to check your superheat and your TD on every one of these evaporator coils. This is very typical. Sometimes you'll have each one of these on an individual condensing unit on the roof, and sometimes what you'll have is you'll have 2 of these tied together, and you'll have 3 of these tied together on 2 separate condensing units on the roof. So anytime that you have a multiple evaporator unit, you've got to make sure that you check the TD on each one of these evaporator coils, and you've got to make sure that you check this superheat on each evaporator coil, because it is very common for, let's say that we got all 5 of these tied on one condensing unit. And let's say that this evaporator coil right here, our expansion valve gets a piece of dirt in it and closes shut. Do you think that the walk-in will still make temp with these other 4 coils on a mild day?
Probably, yeah.
Probably. Probably. So the customer thinks the walk-in's working fine. But then as soon as you get a hot day, then the walk-in can't pull down the temperature. You get a hot box. So one way that you can find that if you're out there and working on the piece of equipment is throw your gauge on the unit, throw your gauges on the unit and see what evaporating temperature you're running, and you just run downstairs and check your return air temperature and your supply air temperature on one of the coils. And it should be roughly 10 to 20. If it's not 10 to 20, you got a problem. You got a problem. If you're running high TD across the coil, you got a problem. If you're running low TD across the coil, you got a problem. So if you've got an expansion valve that's got a piece of dirt in it, are you going to be running low TD or high TD?
Brain hurts.
Because your suction pressure is going to be lower because you're not feeding the other evaporator coil. So you're going to be running low TD. So that can clue you in on a problem before the customer even sees that you have a problem. Before you even see that you have a problem. And that's what customers love. Customers love the stuff fixed before they have a problem. Before they have a problem. So you always check it on individual evaporator coils. You may even have one condensing unit for each evaporator. And they only need, 2 of these condensing units when it gets hot outside. And the unit runs on the other 3 condensing units. So you have to make sure that when you're checking, when you're working on a piece of equipment, you've got more than one evaporator coil and more than one condensing unit. You check each individual evaporator coil in each individual condensing unit. All right, here's a meat cutting room. We got a lower TD. Typically, when you see these sandwich-type evaporator coils, these are low airflow evaporator coils. A lot of times they call these silhouette evaporator coils is what they call these. Right? These are real low airflows. If you guys ever work in a meat cutting room, if you ever go to a grocery store and you get the pleasure of going back in the meat cutting room, what you're going to see is you're going to open up the door and you're going to look on the ceiling and the evaporator coils will be hanging from the ceiling. When they cut meat, they cut inside of a walk-in is what they do. They keep the temperature down to keep the bacteria from growing inside of the meat. Right? It's just a big giant walk-in is all it is. So we got lower TD here. So if we got a lower TD, are we going to have lower humidity or a higher humidity in a meat cutting room?
Higher.
Higher.
No, lower.
No, higher. Lower.
The higher the TD,
higher.
the more humidity.
More
The lower the
humidity, so
TD,
higher, yeah.
the lower the humidity. All right,
My meat.
I'm going to stop right there.
Put cheese in the meat room.
We'll continue on with this one Wednesday. Yes, Mr. Buchanan.
Temperature difference between the same across the evaporator and the condenser.
No, your condenser is going to dictate on how efficient the condenser coil is. So the higher the efficiency of the condenser coil, the lower your TD is going to be across the condenser coil.